record this.
Recording in progress.
So one thing you could do, this is called regression. Have you guys done best fit lines in science class? Like where you take data? Okay. So you have a bunch of, like, it's a scatter plot, you have a bunch of data points. They don't necessarily all fall on the line, but they come pretty darn close. This is the same idea. If you go to stat and go to edit and type in all those coordinates, so 3, 5, and -2, those are my x's. Then I do 10, 36, and 15. If you hit stat again and go to calc and select option 5, quad reg, it will actually give you the equation for you really quickly. I shouldn't show this to you guys because now you know. Now, I don't care if you have to show me the work, but this actually gets you all the constants that fit that parabola. So it's actually going through some sort of algorithm to determine what A, B, and C are. Of course, you could also do this, alpha zoom, sorry, make a 3 by 3 matrix. We talked about that as well, and then do the inverse or raise it to -1 power. But I'm not going to work that out because I don't feel like writing it out. But those are the answers. But you could do that. There's a stat feature in the calculator that does it for you. I've recorded this. I'll show you guys again throughout the week how that works. But you could do that. But the answers are, yeah, 2, -3, 1. And then for B, that's just a line, apparently. Looks like all the same slope. Yeah, I think. Yeah, yeah. So that's just going to be -half x plus 3. So I guess the A value is 0 if you try doing that. For 665, what happened in part B? It's 0. It's just a line. And if I for 667, we have a word problem. Those are the points you could use. That's a graph of it. That's the equation. And then for part D, saying when will the bacteria be eliminated? Set A equal to 0. Solve for x. You should get 90. I think it's x minus 90 and x plus 10, I think. And then how long had symptom been in effect before you went to the doctor? I think that's the y-intercept. No, hold on.
Yeah.
No, the y-intercept's 900. Oh, wait. Why is it 10? Hold on. How long has it been infected? I don't get that. Hold on. Now I'm confused. Oh, I guess we hit 1600. He's infected. Is that right? Wait, I'm confused. Oh, I guess that's when that's the first x-intercept. Got it. Wait, no, hold on. I don't know what's going on. Oh, I see why it's 10 because I think it is the first x-intercept. Okay, gotcha. Got it. Extra practice. I'll post the Schoology if you did it. So that's all there. Okay, anything else? No? All right, so let's go to notes. So notes are really short. I'm going to do 2 pages of notes. Afterwards, just work on homework and get it done. And you guys will be doing pages 1, 2, and 3 today. I'll work them out with you guys while you guys are doing it. So yeah, this is going to be very lecture heavy this week. All right, so let's talk about matrix. So it's just so I give my voice a break and someone else can talk. Aiden, can you read the first paragraph, please? Okay, cool. So a lot of databases use matrices to organize for information. Who here shops on Amazon? Most of you guys, right? Okay. So Sarah, so when you go to Amazon, what does it usually, I mean, a kind of personal question, but what does it like pop up for you, like things that usually? Okay, so family stuff. Was that? Okay, perfect. Toilet paper. There you go. So for someone like me, who's got 3 small kids, what do you think might show up on my Amazon?
Diapers.
Thank you. Or diaper liners, right? But how does it know so quickly? I mean, yes, I'm logged in, but also it's able to
Algorithm.
and the algorithm. So, but in order to, when those algorithms are running, it's retrieving data from data that's placed in matrices. That's what's happening. So it sees, oh, I'm 47 years old, I'm married, I got 3 kids, and I probably ordered a lot of that stuff. So it's able to extract that information pretty quickly, right? So that's why we have matrices in the first place. I know right now it looks very dry and boring, like, oh, just a bunch of numbers, but we just want to have a deep understanding of this in case if you do move on to taking like an econ class, or you got to do some coding, you need to have some knowledge of matrices down the road. Of course, if you're not going to do any of that stuff, then it's probably the only time you ever see it. But anyway, this is what we do in this class. We cover this stuff. Now, the dimensions of a matrix. They have rows and columns. So let's talk about dimensions right now. How many rows does this first matrix have? And how many columns does it have? So we call it a 2 by 2. So given that, what would I call the second matrix? How many rows and columns? A 2 by, how about the next one? Think, go ahead.
Oh, yes.
Oh, you just read no words. How about the last one? 3 by 4. Perfect. So we're going to be doing word problems. We're going to organize this in the matrix. You could probably see why we use this for solving equations, because we organize all those coefficients in the stuff. Okay, so here we got actually kind of a real life problem, I suppose. Nathan, can you read the example, please?
A company manufactures small and large bookshelves. Each size of the bookshelf is available in 3 types of wood: walnut, pine, and cherry. Sales of the racks for the last month and this are shown in the table below.
Perfect, thank you. So we have small bookshelves and large bookshelves. We have colors. We have walnut, pine. Guys, don't throw stuff, please. And we have sales for this month and last month. Okay. So instead of like just giving you all information in a paragraph form, let's organize in a table. However, if we want to do some math with that, let's put it in a matrix. So here's how I'm going to do it. I'm going to make one for the small bookshelves. I'm going to make one for the large bookshelves. Oh, sorry. They said for last month and this month. My bad. Last month and this month. So you got to read the directions, right? Very important. Last month and this month. Okay, here's how you're gonna do it. I'll do S for small and L for large. S for small, L for large. Then I'll do W for walnut, P for pine, and C for cherry. W for walnut, P for pine, C for cherry. So how am I going to fill out that first matrix? If I look at the data from last month, how many small walnut bookshelves I sell last month? So small walnut last month. 95. So put 95 right there. And only focus on small bookshelves. How many small pine did I sell? And how many small cherry? Perfect. And then now you do the next row for large. And this is all for last month only. Only for last month. 114, 215, 300s. So I'm organizing the matrix. So what I deliberately did was I put my size bookshelves as rows and my color bookshelves as columns. You could do it the other way around too, by the way. You didn't have to do small and large as rows. You could do walnut, pine, and cherry as rows and small and large as columns. Totally up to you. Doesn't matter. Just be consistent. That's all I ask. So if you're going to do last month that way, then do this month the same way. You got to be incredibly orderly. I cannot stress that enough. You cannot mix this up. Whatever you commit to for the first matrix, you're going to commit to that through all the other matrices you make. So next month. So we now let's focus on the row right above. Again, small walnut, but this month. How many are small walnut this month? Yep, and then you just go in order. 278, 225, 100, 251, and 270. By the way, is anyone taking the ACT in April or ACT later this year? Okay, so they might throw in a matrix question. I've had some students tell me that after they cover this lesson, they were able to get that question right. It's usually 1 or 2 questions, and it's usually near the end, which they consider to be harder questions. Harder because it's a concept no one's really doesn't see too often. But once you see it, it's not that hard. It's pretty easy. All right, so now they're asking for the average. Okay, so if you're asking for the average, what does that mean?
Add them all up and divide them by the number.
Yeah, exactly. So if I want the average, I'm going to add these two matrices and divide them by 2. That's it. So let's use the calculator to do this. Here we go. I know you guys could do it by hand. It's not that hard, but if we have a calculator, let's just do it. Like, do you really want to do 316 plus 278 in your head and divide that by 2? Probably not. No. 95, 125. I know it's 110 because I'm trying to find what's in between those two numbers. They both end in 5. That was a little easy for me to do mentally, but I don't think I'd want to do all these in my head. So here's what you're going to do. You're going to, and again, you can just watch for now or follow along. It's up to you. Hit alpha zoom. Okay, alpha zoom. Let's make it a 2 by 3. 2 by 3. And just type in the number. So 95, 316, 205, 114. I mean, it's going to take time regardless if you do them individually or do as a matrix. So just kind of have to deal with it. 300 plus the other one, alpha zoom. Hit OK. And you should have 125. Keep moving. 278, 225, 100, 251. I know, very dry and boring. 270. I'll divide by 2 afterwards. So what it did was just add those numbers. That's it. When you add matrices, you're simply adding numbers that correspond to each other. So 95, 125 correspond. You get, I know it's hard to read, 220. 316, 278 adds up to 594. 205 and 225 add to that. I'll write it down below. Then we're going to divide by 2 afterwards. So if I divide 2. Oh, okay, that's interesting. Okay, now actually it's good. I should know that. Okay, so I didn't like that, right? So here's what I'm gonna do. Let me grab that matrix. Oh, here, let me grab it. Or let me do this. Let me add it again. Look, whoa, why is it doing that now? Oh, that's why. Okay, let's try again. All right, instead, what if I multiply by 0.5? Now it likes that. Okay, for some reason it doesn't like the division. I'm glad I did that, but same thing, right? So that's what we get as our average. So I'll write it down below. So that's just going to be 110, 297, 215. So that's the average. And again, I know it's not that hard, but what if you actually had like 100 customers, right? You're not going to add all those up separately. You want to organize all that in a matrix and let the computer system, whatever you got, that's computing this or what software you're using to do it for you. So if you have 100 like stores or clients that are buying your manufacturer bookshelves, you have all these people who are buying your product. Yeah, you want to be able to compute this pretty easily. You don't want to compute by brute force. Does that make sense? Just it's very simple math. The math is actually really easy. Just a new thing you guys are seeing with the matrix. So when you add or subtract, just add or subtract them. That's all. But
this is like just like a more organized way.
100%, 100%. That's all it is. That's all it is. So just make sure the dimensions are the same when you do this. So like, for example, number 3 here, and we just got one more page of notes and then you guys can just get to work. Perform indicated operation. So just using intuition. What do you think I'm gonna do with that 3 on the inside? Sorry, on the outside.
Just distribute it.
Yeah. 12, -3, -9, -15. Easy peasy. Add it to the next sucker, right? -2, -2, 0, 6.
Lose that one as well.
Well, I'll only distribute the 3 into this one.
Yeah, that's okay, never mind.
And then I'm going to add those up. So I get 10, -5, -9, and -9. Done. That's it. For 4, you can use a graphic calculator if you want, or you can just kind of just do it. A plus B. So if you guys want to read for me, what do you think A plus B is going to be? 9, hopefully. 8 plus 1. Okay, what's the next one? Okay, good. Thanks. -3. I'll just do it really fast. Okay. The next one's a little more involved. Why is it more involved? What do you have to do first? Distribute the 3. So 24, -3, 6, 9, -21, and 27.
Is that just for 3A or?
Yeah, and then -2b is going to be 2. I was going to do 2 first. Then I'll do negative afterwards. 2, 0, -10, -8, 12, and 20. And we subtract, just be really, really careful with distributing the minus. That's where mistakes can easily happen. So you should get 22, -3, 16, 17, -33, and 7. Now, one thing you could do, another way you could do this in the calculator, because I'm sure other teachers, or if you have a tutor or someone else, are going to show you something a little different. Here's another way you could do matrices in the calculator. There's actually a matrix button. If you hit second x and -1 power, you can actually choose which matrix to store it. So if I do this one and make a 2 by 3, this is all recorded, so you can watch this later. And if I put the numbers in, I think, what was A again? It was 8, -1, 2. So 8, -1. And make sure you put a negative, not a minus sign, 2. And what was the next row? 3, -7, 9. 3, -7, and 9. Then I'm going to go back and edit matrix B. That's also 2 by 3. And I do 1, 0, -5, -4, 6, and 10. And then what you do is it's kind of a pain in the ass, but hit second x -1. You have to call this up again and do this. That's why I like the shortcut command, the alpha zoom, a little better, because I don't like going back and forth. But you could do that stuff, like that works. Or if I copy it, then I can insert, like say, insert a 3 minus second deletes insert a 2. You do that also. And yeah, there you go. So this way it's stored. So you have that as well, another option. Okay, last 2 problems, and then we're all done for today. And you guys have plenty of time to get some work done. What do you guys think about 5? Using your gut instinct, use your intuition. Okay, well, let's work on the left side. If I combine these two, you're adding 5x to 3, right? But those are not like terms, so I'm gonna leave us 5x plus 3. What's -2 plus 7?
5.
Okay, and the other side is gonna look like this. That's good, because I see 5 on the right side. 6 plus -5 is 1. Awesome. And then -4 minus y. So guess what? 5x plus 3 equals -7. 5x equals -10. X equals -2. And then -4 minus y equals -6. Y equals -2. Y equals 2. Cool. So you just line them up. That's all you're doing. For this one, X is a matrix. So it's a matrix, not a number. Not a single number. Let me fix that. So, What do you think I'm going to put there? Where are you going to add to -5 to get to 7? Or what's 7 minus -5? 12? Does that make sense? What's going to be the next number? We're going to add the 0 to get to -8. -8. How about we're going to add to 4 to get to -3? Good. Yes. Excellent. And we're going to add to -3 to get to 5. There you go. That's it. That's what matrix X is. I've seen problems like this on the ACT. People get really confused because they never learned it. Because actually, sometimes matrices are covered in pre-calculus, not in Algebra 2. Actually, some schools sadly never even cover this topic. I remember spending like a month at least doing this stuff when I took this class 100 years ago. But I don't know, just a lot of competing interests in math classes. But you know, if you see something like this, then you'll know what to do, right? So yeah, maybe that might get you an extra point or two on ACT. That might be a good thing. So anyway, that's all. That's all we're doing today. It's a very short lesson. Homework is right here in the packet. You're just going to do 6.3 homework. There's a system. You could use that little trick I showed you in the calculator to do that. Likewise for 672, I showed you that little trick as well with stats. There's some simplification. There's an exponential problem. There's some HCs. I'll work through these, put the answer, and then some rational functions. So just page 1 through 3. Got a half hour, I guess, to do this. So yeah, just let's get to it, and we're all done for today.